Hello everyone and welcome to new discussion. We are going for a demonstration on GIS software, and today I am going to use ArcView GIS, which is very old version, but it is very convenient, and this I have also discussed in the previous demonstration class. But the same which I am going to show on ArcView can also be done maybe in even much better manner in ArcGIS as well. But since it is very fast, so many times for demonstration purposes I prefer this one. What we are going to discuss here and will be showing that image versus grid differences, and few minutes early part of our demonstration would be spent on this, and then we will go for the generation of tin and also for the generation of tin and boundary issues which we have discussed in the theory class. So, these two things we are going to discuss. So, let us go for now software demonstration. So, in this ArcView GIS software, it is much simpler, and what I am going to do, I am going to open an already existing database which I also showed you through that ArcGIS, so that you would have the feeling that both really works in the same way, but it is very convenient. That is why many times I prefer this one. Of course, currently we are only having in this project the vector data, but we can add the raster data as well. Here first thing is that you have to add extensions. There also in ArcGIS you have to add extensions. So, if I add an extension which is called raster or image analysis also, like spatial analyst extension, and thus with same name it is also called a spatial analyst extension there in ArcView, ArcMap or ArcGIS. So, once I have added these extensions, I will have now much more capabilities to do it. And say if I go for this say image data or a grid data source. So, what I am going to do, I will bring some sample data which is of ISRI and which is very good useful data for such kind of things, and I display here the elevation grid like this. Now, this is our grid data, and currently it is being classified into different classes having these ranges which you can see in this TOC. But the same data, if I choose here the option image, and then same data I can display as image as well, and in that way basically system is taking care about the data in both formats, and the original data will remain the same, but only for display purpose it is now showing as an image rather than as a grid. The data is same. So, many times depending on our requirements we can play with these things and can have this kind of display. Now, that the grid can be also displayed as image, but image cannot be as easily displayed as grid. Now, when I say about the grid, now let me zoom some part here and explore that what are the values here, because what really matters or that the difference between image and grid is that if I click here, this is one cell of my grid, this is more distinct. Say for example, if I click here, I get the value, and that is the real value I am getting in floating, and the precision is very high, and though up to 6 decimal places. But many times as you know, this is elevation value. Elevation value cannot be stored. So, this is showing some redundancy in the elevation value. but doesn't matter. Sometimes if things have not been properly defined, then redundancy may come even in this. So unnecessary it is there, but we are not going to reduce that one. We will discuss these things related with data raster data compression techniques. So anywhere within that cell, if I click, I get the same value. But as soon as I go beyond this cell and click here, I get a separate value. Now here I want to bring a very important discussion about that within this cell, everything is having the same value. Wherever I click, I get the same value, because this cell is representing an aerial average elevation value, because this is digital elevation model. So this is an elevation value, aerial average elevation value, and this is the unit level which I have zoomed this grid up to unit level, and that means I cannot see anything within this one. Whatever is there, it is there, and single value has been assigned, one single attribute has been assigned to each cell of my grid. And the same also happens in case of image, both are raster. So by because of definition, the major difference in the raster and this grid is that in image these values will not be these in real values, they will be integer value. That thing we will also see little later. So what I can do, I can bring a image here, the truly image, not a grid being displayed as image, but a true image here, and then I can show that data also about the image data also. So if I choose a image like this one, which is satellite, which is a spot satellite image, and of course this is quite dark in that sense. So what we can do, we can enhance or stretch. So if I go for say standard deviation stretch, it will look like this now. But about the stretching and other things, that is not a discussion for today. What again, exploring the value, so that we can understand the difference between a grid and an image. So if I zoom say in this part, now I start seeing each individual pixel. So if I zoom further, this is what I get. So if I go for this exploration, because this is colored image, it is made from 3 colors, and we are using a additive color scheme, that is RGB, or which are primary colors also. So for each pixel I am having 3 values against 3 different channels or bands. So even whenever I will click anywhere, I get the same value against each channel. If I change my position and go to the next pixel, here we call as pixel because it is an image, I am getting these values. If it would have been a single band image, then I would be getting values which are which would be only against one layer rather than 3 layers in this example. But important point also here, that the values are being displayed as integers in all 3 channels. So wherever I click, I get the values like in 124, 124, 97. There might be in some cases we may get all values for all 3 channels very different, and sometimes you get a same value. Like here we are getting for against 3 channels for the same pixel, we are getting 3 different values. So that what we saw, that in case of grid, the value, the cell value is coming in decimal or in real numbers, whereas in case of image these values are coming as integer. And so when this situation is there, we call as in case of image we call the unit as pixel. So automatically means when I say pixel, I am talking about an image 1, and the my pixel value is going to be the integer value or whole number. And when I say cell, I am talking about the grid, and that means the cell value is maybe my positive integer, negative integer, or positive real number, negative real number. So all 4 possibilities are there in case of a grid or in case of a cell of a grid. But in case of an image, only positive integer values are assigned or having with pixel. So that's the major difference one has to remember about image versus grid. Both are, though both are raster, and many processes are going to be the same with that. All right. So now I go for the next thing, and I make my this thing clean first. I go for now and add my data to prepare a tin, and for that I because as you know the tin can be prepared using point data. So I am going to using this point data. Let me change the color here so that it becomes very clearly visible, and that is not a big problem because this is the only symbology or data is I can change the symbol as well. So instead of that I can choose this one, and also color I can choose like this. So anything I can I should be able to do it like this and apply, and that's it. Now this is the attribute table, non-spatial data associated with each point which are being shown. So there is a column which is called pH, and as also in the previous discussion I was mentioning that generally pH is recorded up to only 1 decimal place, and that is why one should keep as it is. One should not have 4 or 5 decimal places for pH values. Same generally with the temperatures in degrees centigrade or Fahrenheit, they too are recorded up to 1 decimal place. So in our database we should not go for higher places for after decimal or higher precision, because neither instruments are measuring and nobody is expecting that I would be doing that kind of analysis. And in results I show to somebody that average temperature for this area is 23.5678, then immediately people may ask the question how you have measured, how you have achieved to this figure. So maximum I should say 23.5, that's it. So precision is very important here. I have selected this. I will be using this field which is pH field to generate a tin. So instead of elevation I can use any other field, a numeric field, to create a tin also. So here what I need to do, I need to add an extension which is 3D analyst extension. Same extension is also used in case of ArcGIS with same name, 3D analyst, and once it is done, now I am having an option in this surface because tin is also a surface. So create tin from features, and also in the bottom of this software the small brief help is available to me, which comes in the here just in this part. So when I move put cursor here, it says build tin using selected features in the active feature themes. If I do not select any points, then all points would be considered to create a tin. So this is what I am going to do, that I will go for all points, and the height field or source of height is going to by pH as discussed, and these are my mass points, and value field I am not going to change anything, whatever in the default. just to keep things simple at this stage, and go for interpolation or creating surface, tin surface. So, once I go there, of course, it will ask where to put your data. So, yeah, if I say I want the data to be put here, no problem. Now, the tin has been created, and let me bring these point data on the top, and also change my color here, so that that point data is better displayed here like this. Now, if I explore this tin, then for that I have to zoom it. So, let me zoom it. Now, this is an irregular network of triangles, as you can also feel here, and all these triangles make a facet for us or a plane, and there how you handle. So, if I explore anywhere here, then I get different elevations, because it is representing a facet or a sloping surface or plane. Therefore, I am getting different elevations. Instead of elevations, these are pH values. Remember this, I have taken pH, but rest of the, and accordingly slope and aspect. So, when we were discussing about tin in a theoretical part of the tin, then I said that whenever you generate tin, two more important information are generated, and that is, one is slope and another one is aspect. Whereas in case of raster, these has to be generated in through further processing. But here simultaneously, once the tin is generated, both these informations are also generated and kept with the data and very completely intact. So, that is the biggest advantages of tin. And each triangle is representing different elevations. So, it is not in that way exactly like in case of raster, that within one cell, if I am talking about grid, within one cell every value will remain same, and whereas in case of tin, within a facet or a plane or triangle, I may get different elevation values, and elevation and the slope values, and of course, the aspect value will remain same, because that is the orientation of that plane, sloping plane or facet with reference to north, as you can also see. So, whenever I click here, I am getting the same aspect, whereas my the elevation keep changing like this. See here. So, it depends in which facet I am. On the screen you may see the similar colors, but in fact in the data itself there might be different triangles, and adjacent triangles might be there. Another point which we discuss in theory is that wherever more observations are there, one, and less variations are there, if this is the situation, larger triangles may be formed. But generally, if density of observations are very high, smaller triangles are formed, and wherever you are having a less number of mass points, larger triangles may be formed. And this is what you are seeing here, that here in this part of our tin, we are having points which are very closely associated as compared to these 4 points. So, if I zoom, I am getting small triangles here, but if I zoom in this part, I am getting larger triangles which have been formed. So, as discussed earlier while discussing the tin in a theoretical part, that tin is adaptable to relief roughness or changes, whereas raster cell size is fixed, and within one cell everything is an aerial average. But in case of tin, it is not like that. So, tin is basically a complete different kind of data model to represent a surface. Now, another very important point which we also discuss associated with tin is that if you see this border issue, the boundary issue is here. As long as the data is there, it will form a triangle. That means it cannot do the extrapolation. But in case of if I use the same data set like here, which I am having, the point data set which I used to generate tin. Now what I am going to do, I will use the same data set and generate a raster and then see what really happens. So for that I can create a raster, and that raster we can create using interpolation. Interpolation discussion will come little later. So I will not spend much time on interpolation part, so theoretical part, but I can go for that. So currently what I am going to do, I am saying the extent of my output is going to be same as display. And when I choose this one, that means this entire Windows area is taken as an extent, because I have said output has to be same as my display. And now output grid style, because in case of raster I can decide the spatial resolution, but in case of tin I cannot decide spatial resolution. Currently it is deciding spatial resolution, so I will accept as default values, no problem, but I can change these values to some other spatial resolution. There will not be any problem at all, because if I change a value say here and make it as 2.0 and enter, you will notice that number of rows and columns will also change accordingly. See, it has happened. So let us keep this one, there is no harm, and then we go to the next screen which says next option, that which method of interpolation would you like to adopt. There are various methods, but whatever default is coming, IDW, IDW stands for inverse distance weightage method, I am going to use, and the same field I will use like in case of tin we have used, that is the pH field for Z value. And again the search area and other things, whatever in default, I am going for that thing. And the barriers or break lines here also in raster, I am for time being I am saying no break lines, just taking the default values and go for interpolation. Now interpolation has been done because it is a small set of data set, so good for demonstration, quickly it can be done. Now when I will display, what you would notice that it has covered the entire display area of us, which was available before. Now let me bring first the point data, input point data they are having. So wherever we had the points, between points interpolation has been done, and wherever we did not have observations, that means points, extrapolation has been done. So if I take this part for example, then between these points interpolations is done. Between these points interpolations has done, and inside all these on my right side. But as soon as the margins of point comes, then this is all extrapolation. And as you know that if we do not have observations on the left side here, except for that point data, then of course it is going to be very wild values also. But because you know that raster can only be stored in two shapes, either overall raster, either in rectangular or in square shape. So this current one is definitely in our rectangular shape, one thing. If I display now, if I display my tin over it, what I am seeing that tin was restricted only wherever I had the points, and beyond point, because in tin there is no concept of extrapolation, not at all. Each mass point, each point is used to create a triangle or a facet, rather instead of calling triangle we can call as facet. Even for in this case like here, if you see here, this is one point, this is one point, and maybe little lower. So here no extrapolation, this point, this point, this point has been used to create a triangle. Recall our Delaunay theorem, which says that a circle should be drawn in a manner that only 3 points it should connect, not any, and then that triangle is formed. So, this is how these facets are formed. So, now the issue about the boundary. The tin will not make a rectangular or square shaped boundary as in case of raster, and therefore, you are having boundary problems. I can make subset of my raster very easily, but I cannot make subset of my tin. So, when discussing about tin, I said that if at all I need a subset of that thing, then first what I should do, I should create a subset of input point first, and then use those subsetted points to create a tin, because they otherwise later on a subset of tin cannot be created, whereas a subset of raster can be created very easily. So, this can also be demonstrated, for which I need an extension, and which I will add here very quickly, which is many years back it was developed by myself only. So, here we can extract some data. One more extension would be required. Okay, so now I am having this extension which is called grid analyst extension, which was developed many years back by myself. So, what I am going to do, I am going to create a subset of the raster which we have just created. So, first thing what I need to do, I need to draw a polygon over it, and once I have done it, then like here. So, I will deliberately draw a polygon which is not really rectangular or square in shape. So, therefore, I can demonstrate some other interesting thing about GIS capabilities. I have created a polygon which is not really a rectangular or square, but remember that a raster can only be stored either in only two shapes, either a square or rectangular. So, what would happen in this case? Two things we are going together. One is making a subset of raster which we have just created, and see what happens to this scenario when my polygon is not really fitting in a rectangular or a squared shape. So, I will say extract a grid using selected graphics. This option I will go, and as soon as I do it, it has done it. And the colors may change, do not worry, colors we can bring the same colors as the previous one, there is no issue at all. Same colors I can go for that. And now see, this is a subset of that original one. Values wise everything is same, except that these colors have changed, but I can bring the original colors as well. But just to see both differently, and let us keep this scheme of colors or enhancement. Now, what I am seeing here, that this is my original data, and the shape was completely different of that polygon. Exactly using that polygon it has extracted. So when I see this one, this is what I am getting now. And it is also satisfying that condition that overall shape here is now rectangular. So what happens to the area which do not have any value? And in GIS, in modern GIS, these values are stored as no data, as you can see here. So I am not getting any value if I click on this black part. As soon as I go on the digital elevation model part, I get the values. Like here, no value, like here, no value. I can also play a little with this and say that this no data value should not have any value whatsoever. So don't feel that now raster has become a other shape than square or rectangular, not at all. Only for display what I said that no data values should be displayed without any color. That means they should mix with the background of the screen. Currently the background is white, so it is mixing with that, and I see a grid, I see a digital elevation model having an arbitrary shape. But in fact the system is storing in a completely rectangular fashion. So, but in case of tin, I cannot make any subset. There is no tool exist. This tool is of course is not going to work because this only says that a grid. So you will not find any tool anywhere which can make a subset of tin. So that is one of the limitations with the tin. However, as I have said, if you are ultimately going to make a subset, better first make the subset of point data and then create tin. There will not be any big problem in that way. But the boundary issues will always be there. The boundary issues will always be there. Now let me also prepare one other way of little different, that instead of saying same as display for the output extent, I will say same as my data. And what is my input data is the soil map. And here I am keeping the same resolution as I did previously. So I get the same resolution, and then I choose here same method of interpolation and same field. Rest of the things are remaining same. Now see what happens here. It has created a raster out of my input data, and see what is happening now. That it has only created raster till where it got the extent, covering entire input points. And since if you compare this one, if you compare with the tin, then tin will also go, but because theoretically or practically the raster has to be stored in either in rectangular or grid form, because it is a two-dimensional matrix and number of rows and columns need not to be the same. So two shapes are only possible, rectangular or square. But in case of tin, this condition is not there. So see, in the border areas, if I zoom this part, you would see, let me get rid of this polygon which I created earlier. So see this border area, the tin is just touching those points and creating triangles. But here in case of raster, beyond these observations, it has done the extrapolation. So whatever the area which you are seeing beyond points is all extrapolated, but overall shape is of your raster is rectangle. So the border issue is always a big issue in case of tin, but boundary issue in case of raster is not a issue at all, because if I extract, then using this concept of no data, which we will have separate discussion, then I can still see an arbitrary shape, but at the same time our system is storing data in two-dimensional matrix. So, this brings to the end of this demonstration, and I hope that by now you must be able to get either of these softwares or even QGIS or GRAS, which are the open source software, and start doing the same exercises which I have done on these softwares, and see that how get the feeling of the data, how system stores the data, how you can generate the data, and how you can compare different data sets, vector and TIN and raster. So that then you will understand the efficacies or advantages associated with each type of data model, and of course disadvantages of all types of data models, including your non-spatial data. So this brings to the end of this discussion. Thank you very much.